Hey guys, welcome back. Today we'll be talking about the very end of Chapter 6, Section 3, so we're going to talk about a few of the equations that we see at the end of that section, as well as the even-odd properties. And that'll help us out with some of the homework problems assigned for this week. Okay, so to start off, the first equation that we're talking about, I'm just going to write this out, and then we'll talk about where it comes from. We have this equation where we have sine squared of theta plus cosine squared of theta is equal to 1. And so one note is that sine of theta squared is usually written as sine squared of theta. So when we raise trig functions to a power, like squaring it, the convention is to write the power actually before we write the argument or the input into the trig function. So it can be a little confusing when you first see it, but just note that what this means is that we're actually evaluating sine of theta, and then we're squaring that value after we put theta into sine, find the sine value. Okay, so sine squared of theta, in other words, sine of theta squared plus cosine of theta squared is equal to 1. And we can see this by using actually the right triangles that we've been working with in the unit circle. So if we think back to the unit circle, looks something like this. And we can think of a triangle within the unit circle right here. We have a right triangle, and here's our point on the unit circle. So as we've discussed in the past, the x value is going to be the same thing as the cosine value of theta, if theta is this angle on the bottom left there. And then the y value is the same as the sine value of theta. And so really we have a hypotenuse of 1 because it's a unit circle. All we're saying here is the Pythagorean theorem, except we're writing the side lengths in terms of sine and cosine. So we know that if we have two legs, if we square each leg and add them up, we should end up with the hypotenuse squared. A squared plus b squared equals c squared. So in this case, sine squared, in other words, the y leg, plus cosine squared, in other words, the x leg squared, is equal to 1 squared, which just gives us 1. So this equation, or this identity, can be really helpful when working with trig functions in the future, because we can always, if we're trying to find like the cosine value and we only have the sine value, we can use this to help us out. From this equation, we can see the two other equations listed just below it, and we can find these other equations which use tangent and secant, cotangent and cosecant, those other trig functions we've talked about a little bit earlier. We can see these by dividing the entire equation by either cosine squared or sine squared. So let's write it out. So let's look at sine squared of theta plus cosine squared of theta equals 1. If we were to divide everything by cosine squared of theta divided by cosine squared of theta. And one note is that when we do this, we need to make sure that theta is not equal to anything that would make cosine 0. So it's going to be pi over 2 and then 3 pi over 2. And any multiple plus or minus 2 pi of those. So we can divide everything by cosine squared, and then we know that sine over cosine, so we can rewrite this as sine of theta over cosine of theta squared. Sine over cosine is the same thing as tangent. Tangent of theta is equal to sine of theta over cosine of theta, plus cosine squared plus over cosine squared is 1, equals 1 over cosine theta squared. So we can actually replace this expression inside of our parentheses with tangent. So tangent squared of theta plus 1 is equal to, and then 1 over cosine is the same thing as secant of theta, is 1 over cosine theta. So tangent squared of theta plus 1 is equal to secant squared of theta. Similarly, if we take our original equation, sine squared theta plus cosine squared theta equals 1, and we divide instead by sine squared of theta. Again, making sure that theta isn't something that makes sine squared or sine of theta is 0 over sine squared theta. We can rewrite this as 1 plus we have cosine of theta over sine of theta squared equals 1 over sine of theta squared. And then what we have here is we know that tangent of theta is sine of theta over cosine theta. And we know that cotangent of theta is the reciprocal, 1 over tangent of theta. Which, if we were to rewrite this using this quotient here, or this fraction, this ratio, we end up with 1 over sine theta over cosine theta, which is the same thing as 1 times the reciprocal of that, whatever we're dividing. 1 times cosine theta over sine theta. In other words, cotangent of theta is just the reciprocal of tangent. We have cosine of theta in the top and then sine of theta in the bottom. So looking back at our equation that we're transforming, we have 1 plus cotangent squared of theta is equal to, and then we know that cosecant of theta is 1 over sine theta. So we have cosecant squared of theta. So we have our original equation, which we found up here. And then we're given 2 other equations, both of which we can find by just dividing by cosine squared, dividing all the terms by cosine squared, or dividing all the terms by sine squared. There's one of our equations. Here's our other equation that we get. And we can derive those from the original equation by doing that division. And so we can use these to find, if we're given one value, we can easily find the other value. If you're given a sine of theta and you're asked to find the cosine value, then all you need to do is plug it into this equation and then simplify. We're going to go over one more property called the even-odd properties. So if you remember, we talked about even and odd functions earlier in the semester. And sine and cosine kind of follow some of those even and odd properties that we talked about. So, for example, if we have sine of negative theta, that's going to be the same as the negative sine of theta. So thinking back to our even and odd functions, for even functions, we saw that f of negative x, actually for odd functions, we saw that f of negative x is equal to negative f of x. And this is the same idea. We have the negative input and we get the negative output of theta. And one way to think about this is look at the unit circle and think about what we're doing when we take a negative input. So for example, if we look at theta, and here's our point on the unit circle, and sine is going to be the y value of theta. So here we have sine theta. If we were to instead go negative theta, in other words, start at the positive x-axis and then go down by theta, then what this is saying is we end up with the same y value, the same y distance, but in the negative direction. So we have negative sine of theta right here. So if we go up by theta, then going down by theta is just going to give you the negative output. Cosine, on the other hand, has the property where that we looked at for even functions, where f of x is equal to f of negative x. In other words, cosine of theta is equal to cosine of negative theta. And again, we can see this by looking at our unit circle. So here we know that cosine of theta is this x distance. So this is cosine of theta for theta. And we know that if we were to go in the opposite direction, go down by theta, then it's going to be the same x distance. So the y value has flipped or become negative, but the x distance is still the same. It hasn't changed. And if you look at our special points on our unit circle, which we've talked about in the past, like pi over 3, pi over 6, pi over 4, you'll see these patterns show up, where cosine of theta is equal to cosine of negative theta. And we can use this to really quickly find different sine and cosine values. Like if you're asked to find sine of negative 45 degrees, you know that's the same thing as the negative sine of 45 degrees. So again, it's kind of like a shortcut to help us with evaluating sine and cosine functions. Okay, so in this video, we took a look at even and odd properties. So in other words, what happens when we put the negative input into sine and cosine. We also talked about, we started to look at some equations to help us with simplifying or finding other trig functions given one of the trig functions. So sine squared plus cosine squared equals 1, for example.